So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the series of going through some GCSE Maths higher big mark questions taken from some higher past papers. Now as always there'll be a copy of the questions along with the mark scheme available for you to download and have an attempt at before watching through this video, and again I'll include the mark scheme just so you can see that there are more than one way of finding the answer, and you can also see how many marks you attained in your efforts. Now, as you can see in the question breakdown of the 5 questions we're going to go through in this video, that there isn't many, if any, amalgamation of any maths topic. So each question is going to be exclusive to one topic. And obviously, as you can see, there is a mixture of some non-calculator and some calculator questions. So let's get started on question 1. Now, if you've not had an opportunity to print out and have an attempt at any of these questions, then I strongly recommend you pause the video, have an attempt at the question, and then unpause so you can watch to see if you've got the question correct. So looking at its first question, it says that the shape is made of 2 sectors and 2 squares of side 8 centimeters. The radius of each sector is also 8 centimeters, and the question is asking us to work out the total area of the shape. Now it may not seem like it, but there are 2 sectors in this particular shape. So here we've got 1. Now we know that this is 8 centimeters and that's going to be 8. So the area of this square is going to be 64 centimeters square. And so is this one here. And that's going to have 8. This is going to be 8. And this is going to be 8. Now, one problem about working out the area of these sectors is that you might notice that we've got no indication about what the size of these angles are. So if I just call it X and Y, now as you can see with regards to those 2 sectors, that the radius for both of these is the same, it's both 8. Now one thing we can find with this is that one of the key properties of a square is that the internal angles are 90 degrees. So here what we've got is we've got X plus Y plus 90 plus 90 equals 360, which therefore means that X plus Y equals 180. So this sector here and this sector here, if we join them together, would actually make a semicircle, and a semicircle with a radius of 8 centimeters. So from this we can then work that out. So here the area of the sector, or sectors I should say, because I'm working them together, is going to be 180 over 360 multiplied by pi times 8 squared. So this is going to be a half, so it's going to be a half times pi times 64, which gives me an answer of 32 pi. So then working out the total area in terms of pi is going to be 64 plus 64 plus, I don't know what's happened there, plus 32 pi, which gives me an answer of 128 plus 32 pi, and if I wanted to work that out on my calculator, it'll be 228.5 centimeter squared. And there we go. So we've got 2 possible answers depending on if it's a non-calculated question, in which I give my answer in terms of pi, or if it's on a calculated paper, I can give my answer as a decimal. And again, if you have rounded it up, always make sure that you are stating to what degree of accuracy you have rounded it up to. Then moving on to question 2, it says Paul travels from Rye to Weston on at an average speed of 90 kilometers per hour. He travels for T hours. Mary makes the same journey at an average speed of 70 kilometers per hour. She travels for 1 hour longer than Paul. And the question is asking us to work out the value of T. So just by writing down what we know, so we know that Paul, in terms of time, or I should say in terms of distance, because they both travel the same distance, is going to be the speed multiplied by the time. So for Paul, that's going to be 90 multiplied by T hours. So that gives me an answer of 90T. Then if we look at Mary, well, she travelled 70 kilometers per hour, and she travelled T plus 1. So that's going to be equal to 70 T plus 1. Now we know that both of these 2 things have both got to equal the same because they've both travelled the same distance. and it says that because they both made the same distance journey. So here we've got 90t equals 70t plus 1, which gives me 90t equals 70t plus 70. So 20t equals 70. So t equals 70 over 20, which gives me an answer of 3.5 hours. Then moving on to question 3, it says that we've got A and B are independent events, and it says fill in all 8 missing probabilities in the diagram below. So what we know about probability trees is that each set of branches has got to add up to equal 1. So this branch here plus this branch here has got to add up to 1, so that means that this must be 0.7. Then moving on to the second branch, well, we know that this probability multiplied by this one should equal 0.12. So if I do 0.12 divided by 0.3, that gives me an answer of 0.4. So this is going to be 0.4, and if that's 0.4, this is going to be 0.6, and then because the events are independent, it's also going to have the same probability, and then I just multiply across. So 0.3 multiplied by 0.6 is 0.18. 0.7 times 0.4 is 0.28, and 0.7 times 0.6 is 0.42. Then moving on to question 4, it says that the building block is in the shape of a cuboid. The block contains one steel cylindrical rod of length of 90 centimeters. The radius of the rod is 4 centimeters. The rest of the block is concrete. Work out the volume of the concrete. So the volume of the concrete, if I could spell it, which I can't, let's just try that again. So the volume of the concrete is equal to the volume of the cuboid minus the volume of the cylinder. So from this, if we look at the cuboid, well, the volume of the cuboid is going to be 20 multiplied by 15 multiplied by 90. You just want to double make sure to make sure all the units are the same, in which they are. Then the volume of the cylinder, well, that's going to be pi r squared times h, or the L, depending on whatever you prefer. So then looking at that, we're going to end up with pi times 4 squared multiplied by the length, which is 90. So it's going to be 20 times 15 times 90 minus, and it's going to be 16 times 90 times pi. And typing that all into my calculator, I get 27000 minus 1440 pi, and working that on my calculator, I get an answer of 22,476.1, and that's going to be in centimetre cubed, and that's been rounded to 1 decimal place. Then moving on to our last question, it says that the maximum safe load of a bridge is 1500 kilograms to the nearest 10 kilograms. An average soldier is 75 kilograms to the nearest kilogram. Work out an estimate for the maximum number of soldiers that can safely cross the bridge at the same time. Now for this, what we want to look at is the worst case scenario. Now the worst case scenario is going to be a weak bridge and a heavy soldier. So from this, what we can then see is, well, looking at the upper and lower bound, so if we calculate that next, so here for the bridge, it's going to be 1500 plus or minus, I halve the rounding error, which is 10, which is going to give me 5, so that's going to give me 1495 to 1505. Then with the soldiers, that's been rounded up to the nearest kilogram, so that's going to be 1 divided by 2 is a half, so it's going to be 74.5 to 75.5. So looking at the worst case scenario, the values that I want to pick out is the lightest bridge, which is that, and the heaviest soldiers. So for this, what we then need to type in is 1495 divided by 75.5, and then on my calculator I get an answer of 19.8 something something, and so therefore we need to round down, so the answer then is going to be 19 soldiers.